right, first thing we're going to do is a little bit of a review. Then we have an activity, and I'll be checking your notebook when you're doing the activity. Okay, so on this right here, I need to do this problem. The first thing you need to ask yourself is, does it have a like base? I'm multiplying, does it have a like base? What is the base? This is the base, exactly like that. And then you add your exponents. My question to you, is that the same thing as this? No, they're not. What's the difference between them, Garrett?
One would cancel off the negative, right?
Correct. Exactly. This one is being raised to the 6th power, so we know that ends up being positive. The only thing being raised to the 6th power on this one is the 3. So these are not the same. That's why it's important that you know what the base is. If it's in parentheses with a negative, then it stays in the parentheses with the negative, unless you're evaluating it to get a final answer. Those two do not equal each other. All right. For the next one, there was an area problem. What kind of triangle is that? Besides the little marking that I went off to the side on. What kind of triangle is it? It's an equilateral, which means exactly, all of the sides are the same. And they give you a formula. Substitute it in. We know, whoops, that's a 3. We know what S is. And then simplify as much as you can. Can I simplify? What? In the order of operations, what comes first? Exponent, so that's where I should be focused on right now. Always, forever, right? PEMDAS, you think it's some element to everything, but it has order, as does the world in your body. Everything has order. There are rules. What do you got, Lily? Exactly. You're squaring the numerator and you're squaring the denominator, or as Lily said, you're doing x divided by 3 times x divided by 3. So we have the square root of 3 divided by 4, and then x being squared is x squared. The 3 being squared is 9. Order of operations, my exponents are done. I only kept the parentheses to show multiplication because it's still being multiplied. I could have used the dot. Am I done? Where do I simplify?
Multiply the denominators.
That's it. Yes. And you multiply the numerators. That's all you can do. How do I multiply the numerator? I could just say that it's x squared, square root of 3, or the other way. It doesn't matter. And then the 36. That's as far as I can go on it. We don't convert square roots, irrational numbers, unless we're going to graph. If I'm going to graph something, then I'll change it to something, an estimate. That's a perfect number right there, right now. It's not an estimate. So we never convert them unless we're graphing. And then we need to know where it is on the graph. All right, the next one, reviewing this, but I did show you another way to do it, which would be to break it down into one of them and practicing a square, a binomial squared. Practicing that binomial square so that every time you see them, you're not expanding them, and you guys are I can already see it already. You're getting better at them, and that we need to keep practicing them. It is. I know that marker's terrible. This one is squared. So I bring down the first one because I'm not using it yet. And then I'm going to square that binomial. It's easy to see the first term, 7x squared. What is 7x squared? 49x squared. 7x times 7x is 49x squared. The middle term I've had to write down on a few assignments. I go off to the side and I write middle term. And the middle term is always 2 times the first term, a, times the second term, which includes any negatives. 2 times a times b. So we get negative 14xy. And then negative y squared is going to be a positive y squared. And I want to encourage some of the distributing that's happening here. Your numbers stay lined up better if you take the first number in the binomial and the trinomial. If you take the first number as 7x and multiply it 3 times before you move on to the negative y. So 7x, oh, these are big numbers. Here's my calculator. Let's see, 49 times 7. So we get 343. And that's going to be x cubed. And then we get negative 98 x squared y. You guys did really good on this part right here. We did really good in keeping track of the fact that we had an x squared and a y on that term. And then the last one would be a 7xy squared. And now I'm ready to move on to the other term. So I would have negative y times 49x squared. So I have an x squared y. I'm looking for x squared in a y column right here. And that would be negative 49x squared y. And then I'm going to have an xy squared, which should be the next one if I keep going in order. And that's going to be a positive 14 xy squared. And then a negative y cubed. Add them up. All right. For the next part, but this problem is a very basic problem. As a matter, I only had 3 numbers written down. This is p of x and q of x. It says, when I add p of x and q of x, what's the degree going to be? And again, this is not the same exact problem in the homework. So I'm adding these 2 up. I can just look at them and add them. What's the first term going to be? X cubed. It doesn't have anything to combine with, does it? So I know it's x cubed. I don't need to go any further. It's asking me about the degree. What's the degree of this problem? The next one says p of x minus q of x. What do I need to be careful about on this one? I'm subtracting q of x, so I might want to write minus x plus 5 above it just to make sure I'm getting everything I need. I'm just subtracting them. So what's the first term I'm going to look at? Yep, so if I have p of x right here, subtracting q of x right here, how do I start subtracting it? Where do I look? Exactly. I'm doing x cubed, and what am I subtracting? Anything? No, right? Because there's nothing here that has x cubed in it, right? It's just x cubed, and I'm looking. It's going to be minus x minus 5, and that's not going to help me with x cubed. So again, the term is x cubed, which is a degree 3. Now it says p of x times q of x. So if I just have x cubed minus 7x plus 4, and I'm multiplying to x plus 5, what's my first term going to be? What do you got, Megan? I'm multiplying. Which is x to the 4th, and if I go further, I get x cubed. Am I going to get anything higher than that degree 4? If you're not sure, you would just multiply it out, right? What degree is this problem? That's it. That's all you had to do on these ones. But again, if you're not feeling sure, you would have multiplied these out, no big deal, right? Hopefully you can see adding and subtracting a little bit easier, and multiplying. If they're not in order, you got to be careful. These were all in order. They were in descending order. So I knew all my terms were going to be descending. But if these are not in descending order, I could trick you, and I just might. And just kind of practice some problems. There's a couple different ways of looking at doing this type of factoring. We're on cubics now. right? One thing you should know is that a cubed plus b cubed does not equal a plus b cubed. Those are not the same. And so there are two different ways. The video had one. Here's the second way. If you like using formulas and you're good with that, then I can look at this and it says a plus b cubed. Well, what do? I take one of each, and then it's going to be an a squared, and then I can do a negative times a times b, and then it's going to be a b squared. So you can do it that way. And I'll show you how right now in the next problem. Q cubed plus 1. And so the first thing you would do is you would take one of everything, q and a 1. This is a cube. That's important that they actually look like cubes. 1 is a cube. So I would just do q plus 1. Take one of each. And now it says you're going to square your a term. Here's my a term. Okay, so the first one is the formula. This is the formula. Okay, that's a formula. If I want to factor a cubed plus b cubed, there's a formula for it. That's the formula. It's in your notes. And then how do I use the formula is how I'm showing you right now on an example. It says that you're going to take one of each. So I took a q and a 1, q plus 1. And then it says you're going to square your a term. So here's my a term. Q squared is q squared. Here's the middle term. It says that you're going to have a negative times a times b. So negative times a times b. Negative q times 1 is still negative q. And then it says to square the last term. B squared, so 1 squared, which is just 1. And you would still have to check to see if this is going to factor at all. It's a quadratic. So this still might factor right here, but I know that having a 1 and a 1 is never going to add to a negative 1. So I know it doesn't factor anymore. All right, let's try one that's a little more difficult. These do not look like cubes. I need to make them look like cubes. So how can I change this one to look like a cube? Well, you want to have this term be a cube. Right now, only the y is cubed. What about 8? Can I make 8 into a cube? What would 8 be as a cube? 2 cubed, right? 2 times 2 times 2. So I'm going to go like this. 2 cubed is still 8, and it still says y to the third power. So this is really my a term now right now. 2y is the a term in my formula. And then minus, what's 125 as a cube? 5 cubed. So in the formula, 2y is my a, and 5 is my b, just the 5. And that's not actually, I don't have the formula up there for the minus. The signs are different. So I'm pretty sure that it's just going to be, okay, I need to rewrite my formula right now. We'll write it right here. It's going to be a cubed minus b cubed, whoops, equals a minus b. A cubed minus b cubed. This has, the signs are different. A squared, so plus ab plus b squared. 2y is my a. 5 is my b. So it's a minus b. So I have 2y minus 5. And then it says a squared. So I'm going to use square brackets and just put 2y squared. A minus b, there's my a minus b. And then it says a squared. So there's 2y being squared plus it's a times b. So that's 2y times 5. And I'm going to write that in there. It's going to be 2y times 5. And again, when you get used to doing this, we're just going to have to keep practicing every beginning of the class. It's by practice that it starts to sink in. You would do that in your head, and you would just say 10y. And then the last term is 5 squared. And then you just simplify what you have there. Let's look at factoring by regrouping. which I think that you saw in chapter 2, but we never used it. But this is a cubic. Factoring by regrouping means I'm going to factor the first two terms, and then I'm going to factor the last two terms, and then I'm going to look at what I have. What's the greatest common factor for x cubed and 2x squared? What do they have in common? They both have an x. What's the highest x they both have? So we have x squared that they have in common. Now I'm going to write down, I'm factoring it out. It's like I'm doing the distributive property. We're going to factor out x squared. Lily, when I factor out x squared, what's going to be left? Correct. So if factoring by regrouping works, I better get another parenthesis that has an x plus 2. Otherwise, I can't use it. So when I come over here, Brendan, what's the greatest common factor for these two? 3. Coates, what's left? When I pull a 3 out, what's left? X plus 2. Now I have to write my final answer. I'm going to do the distributive property again, but to the whole thing. There's two terms right here. This is the first term. This is the second term. There's multiplying here. So that means that's one whole term. These are two terms. Out of these two terms, what do they have in common that I can factor out from them? They have an x plus 2. And then I write down what's left. An x squared and a positive 3 is left. X squared and a positive 3 is left. Let's try it one more time. Go ahead and try the next one. Start it off. So I do just kind of put a little line right there. Just keep it separated. Garrett, what can I take out? What's the greatest common factor for the first two terms?
3 cubed.
X cubed.
X cubed, sorry.
Yep. And then what's left when you pull an x cubed out?
2x.
Correct. Okay, Griffin. For the next one, what's the common factor for the second pair? And then what's left when I do that? 2x. If I multiply that back together, very good. Yep. I can always check and multiply it back together and see if I get the same. And now I can write my final answer. I can pull a 2x minus 1 out of both of them, and it leaves an x cubed and a positive 3. X cubed plus 3.